Bigger things to worry about than that right now.
Yeah, that's a lot better.
Oh, great. Thank God. Okay.
Yeah, your video is not pixelated anymore.
Okay. Great.
I think your video will just pop up.
Okay.
Okay.
All right. I'm going to cut to the chase here because it's 8:23. I'm sorry, guys. You know how computers can be. Okay. So for the third time, I'm going to start again here. But you know, this is about the triads, so it's okay. Okay. So I want to discuss Vernadsky and the second triad, and you know, which is something that Lynn brought up a couple months ago, and since then, there's been a lot more that we have in terms of ways to think about Vernadsky. There's Lynn's 4 points. There's Lynn's 4 points. There is the presentation that Dennis did, which I was really excited about at the webcast, and I actually sort of want to, you know, pick up on some of what he brought up. And I will let people know that next week we're going to have Bill Jones doing a presentation on Vernadsky next Sunday, which will be really great. He knows a lot about Vernadsky as a person, Vernadsky's life, and also has done this original translation of parts of the scientific thought paper. So we have that to look forward to. So anyhow, I know that there's a lot already out there, but Vernadsky was a very productive guy, so there's always more that you can throw into the pot. He did a lot. He has a lot of important ideas. But so what I want to focus on specifically tonight, and of course it's also, you know, you need more than one class to really explore everything that he did. I want to focus on this idea of Vernadsky as part of this second triad with Planck and Einstein, and try to fill out a concept of that. So what I want to do is start, and I want to read from, sorry, one sec, paper that Lynn wrote in April called Building the Real American Party, where he introduced this idea as one of the first papers where he brought this up, and it's a paper that we actually discussed in terms of getting an idea of these triads and their role in the educational program, as we've been discussing. So I just want to read this. So Lynn says, the characteristics of the human mind are not simple. They're intrinsically noetic, never deductive as such. That is expressed as a nonlinear scale of increase of the effective energy flux density of the activity of the human mind. For this purpose, my own representation of the principles of physical science is typified by me here first as the Brunelleschi-Kusa-Kepler and then the Planck-Einstein-Vernadsky sequence typifies in practice the nature of the human mind as distinct from the mere reductionists. In brief, 1900 to 2014 has been, this far, the interval of a new dark age of transatlantic mankind. That is the crisis. There is the remedy. So I really like that. Lynn, he's really clear. You've had this dark age in the 20th century science, culture, politics, you know, really everything. And he puts forward these triads as the remedy. And of course, the uniqueness of the second triad is that they actually all existed in the midst of this dark age in 20th century science. And I think that's a very important point to make. We have been talking to, I think Cody actually did a very good presentation a couple weeks ago on the weekly report, where he looked at, he got to the idea of these three, and the fact that, in a sense, what unifies them is that they all recognize, sorry, kept this quote up on the screen, they all recognize the unique power of the human mind as subsuming physics, chemistry, biology. They all really got to that idea in their work. And the point that I really want to make, specifically with Vernadsky tonight, and I think people maybe have a clearer concept of this with Einstein and Planck, is that they weren't just putting forward this as a nice idea that people agreed with, because of course they were in the midst of this scientific dark age. where there was a plague of reductionism. So them putting forward this idea of the superiority of the human mind, I mean, there was a real fight around that. And I think people are familiar with, maybe more familiar, Planck and Einstein, their fight against what was done with the work that they did in terms of the discovery of the quantum, this Copenhagen interpretation of quantum mechanics, which essentially, what was the point? It's the opposite of saying the mind is something superior. It's totally degrading the mind, because you say the universe is fundamentally unknowable, that's what, that somehow that's what Planck's discovery of the quantum led to. And of course, he and Einstein disagreed with this. They were very vocal about that. And Lynn has also made the point about ultimately Bertrand Russell's very explicit, evil, and really political role in this, in orchestrating this, in the subversion of their work, and generally, causing this scientific dark age. So I just want to, because it's always good for people to cultivate their hatred of Bertrand Russell, I'll give you my new most evil Bertrand Russell quote that I dug up. And I like this one because it makes this specific point. It makes very clear how Russell was taking the discoveries of, in this case Einstein, being an evil sophist about it, and twisting it to make a very evil point. So this is from a book he wrote, misnamed, I guess, The ABCs of Relativity, from 1925. So Russell says, causation in the old sense no longer has a place in theoretical physics. The collapse of the notion of one all-embracing time in which all events can be dated must in the long run affect our views as to cause and effect, evolution, and many other matters. For instance, the question whether, on the whole, there is progress in the universe may depend upon our choice of a measuring of time. If we choose out of a number of equally good clocks, we may find that the universe is progressing as fast as the most optimistic American thinks it is. If we choose another equally good clock, we may find that the universe is going from bad to worse as fast as the most melancholy Slav could imagine. This optimism and pessimism are neither true nor false, but depend upon the choice of clocks. So I was happy. I actually went to a used book sale yesterday, and I saw this book there. So I was glad that somebody realized they should get rid of it. But I mean, that really, that really speaks for itself. This is what this guy was doing. Now, and this is some of what I'm going to go through was actually in an article that was part of this Vernadsky 150th anniversary 21st century that we put together. Looking at specifically what I'm going to go through now. So a point that I make in there is, in the 20th century, while Russell, he took care of physics, you could say, clearly. But there were other people of similar ilk, these British oligarchical figures, who, and you'll recognize some of the names. We're talking about the Huxleys, the Welleses. These guys moved in on biology. And there they imposed a doctrine of reductionism, and this is exactly what Vernadsky fought against. And this was the context for his fight with this character who Lynn has referred to, Alexander Oparin. But the point that I want to make is Oparin is really this, while Oparin and Vernadsky were figures in Russia, you have to see the kind of fight that they were engaged in as part of overall. It wasn't it does have a lot to do. It's, they're both Russian, and Russian science is very important, but it all took place in the context of this dark age that was occurring in the 20th century in Europe, in science overall. And what I want to proceed looking at Oparin with is some of these British figures who actually made some of his specific arguments before him. So just to look at how Lynn actually brought this up recently, I want to look at the weekly report. This was interesting. This is from the June 11th weekly report with Michael, and Michael actually asked Lynn, and this also gives a sense of it's another interesting sort of way of thinking about the importance of Vernadsky, and also I think another angle in terms of thinking about how it relates to the 4 points. Michael asked Lynn for his thoughts on Glaziev and some of what Glaziev has been putting forward, and this is what Lynn said. And this, fight in Russia in terms of economic policy between Glaziev and Kudrin. And so what Lynn said is, Kudrin represents the sense in the Soviet system essentially also. It's the British end of the Soviet system, and it's against Vernadsky. The opposition of Oparin. One is the Oparin tradition, which is a British tradition. The emerging of a Soviet system out of the British system was Oparin, who was actually under the influence of Bertrand Russell. He was a mathematician, not a scientist, so that is the problem. So that was, interesting and provocative also. I had been provoked for a while, Lynn saying that, Oparin was this tool of Russell. And so looked into that a bit with the help of some other people, Rachel Douglas, people who had some hunches about this. I'm trying to get the video back on me. There. Okay. So, what I want to look at, as I was saying, this question of who is this guy Oparin? We'll get into very explicitly the fight he had with Vernadsky, but why is Lynn saying that this guy? What does he have to do with Bertrand Russell and these? Some of these evil British figures. And as I said, I think the way to look at it is, Russell, he took care of physics, and then he deployed some other people to impose this reductionist ideology in the science of biology. So let's look at this. This book that, again, Rachel Douglas tips me off on this. This is a book written actually the same year as the Biosphere. Vernadsky's Biosphere. It was this huge tome called The Science of Life. And this is written by H.G. Wells, his son, G.P. Wells, and Julian Huxley. And they started this in...
Triad.
Yeah, the Triad of Evil. They started this in 1926, so again, and this is how Rachel actually brought this up to me. She said, this is... when Vernadsky put out the Biosphere, these guys actually came out and attacked the essence of what was in it. So they began this project together in 1926, and they completed it in 1929. And I don't have time today to go through everything in there, and I haven't gone through everything in there myself. I think you can get a good sense of sort of the essence. One of the things that they get to, that they conclude, is after going through all this stuff about, and some of it seems like, oh, this is just science, it's just innocent science, biology, things about nature. They actually proposed renaming Homo sapiens Homo stulus, which means man the fool, because he lacks respect for nature, the environment, etc. So they introduce this very explicitly. They say we should just change the name of the species, man the fool, not man the maker. Homo sapiens faber, which is Vernadsky's sense of what man does. And the other thing which is going to get into sort of the meat of this is they put forward this argument which you see in Oparin. And this becomes the fight between Vernadsky and Oparin, which is that they promote the idea of it's a fundamentally reductionist idea of life. That life originated from brute, non-living matter, chemical compounds. This is referred to as the idea of, life originated on Earth in an abiotic primordial soup. And what they cite in there is a British guy. His name is J.B.S. Haldane. He wrote a book in, I think it was during the time they were working on this book. He wrote a book called The Origin of Life, which is the exact same title as the Oparin's book, which actually came out in 1925 or something. So very funny. This British guy writes a book called The Origin of Life, same year as, roughly the same time as Oparin, and it's referenced in this Science of Life book by the Welleses and Huxley. But interestingly, even that guy, even this particular guy who is probably insignificant, Haldane, he wasn't the first one to come up with this. So I want to go back and look a little bit more truthfully at where this came from and why they promoted it, and also just give some quotes to give people a sense of what the concept is. So one of the first people who promoted this idea of life originating from non-life, or abiogenesis, was the grandfather of Julian Huxley, Thomas Huxley, in 1868, and his nickname was Darwin's Bulldog. He did the work of Darwin, did Darwin's dirty work. So in a lecture called The Physical Basis of Life, he asserted that vital action is nothing more than the result of molecular forces of the protoplasm which displays it. Now, this is an interesting anecdote about this. The audience in the lecture was reportedly shocked at this assertion, and the editor of the Fortnightly Review, which published the lecture in 1869, said no article that had appeared in any periodical for a generation had caused such a sensation. So I think we sort of know this is how these characters work, right? They put forward a wild, people think this is crazy, this idea of life just being fundamentally non-living and abiotic. Put it forward, it seems shocking, but they know exactly how they're going to make this the dominant popular way that people think. Then interestingly, Darwin himself, he put forward a similar idea, which is not just his reductionist idea of evolution, but actually a reductionist conception of a living organism. A couple years later, there's a letter from Darwin in 1871. He said the original spark of life might have begun in a warm little pond with all sorts of ammonia, phosphoric salts, lights, heat, electricity, etc. present, so that a protein compound was chemically formed, ready to undergo still more complex changes. So then, anyhow, these guys put this forward, these British figures, this kind of conception. And then later, this is the way that Oparin puts it, but the point is that it's all the same and that it was originally British. Oparin didn't, he's accredited with, in a sense, coming up with it, but he really didn't. In 1923, he says, and this is also just to give you guys an idea of how people express this, he says the carbon atom in the sun's atmosphere does not represent organic matter, but the exceptional capacity of this element to form long atomic chains and to unite with other elements, such as hydrogen, oxygen, and nitrogen, is the hidden spring which, under proper conditions of existence, has furnished the impetus for the formation of organic compounds. So that's, we'll get a little bit more into what he says. One sec. So this is Oparin. He's sort of a homely, funny-looking guy. Wears his bow tie. There's some funny anecdotes about people really didn't like attending his lectures. He was boring, and it was sort of it was problematic. So he was supposed to be famous and important, and students really didn't like hearing him lecture. So just to give you an idea of who is this guy. So A.I. Oparin, Alexander Ivanovich Oparin. So I've read his Origin of Life. It's pretty boring. He cites, and also cited this actually in an article. He made a trip to NASA Ames in actually the 1960s, which is a whole other thing, which is how his ideology has become very dominant. And he cited Aristotle as his intellectual predecessor. Growing up, he was really excited about this guy. It's funny. So Huxley was Darwin's Russian bulldog, and there's Darwin's bulldog, then there's Darwin's Russian bulldog, a guy named Timoryazov. And Oparin attended his lectures. Overall, and again, can't even begin to get into this, the guy was really just a political tool. Here's a quote from him, which is the most economical way to put this. He said, "The attempts to create living systems are possible only in the Soviet Union. Such attempts are not possible anywhere in capitalist countries because of the ideological position." Not very scientific or rigorous. So what he says in the introduction to his book is he says he acknowledges, and I can't get into this all tonight, but some of this is actually in the very good article that the Denise and Roger Ham wrote on Pasteur, who himself countered, did experiments and fought and disproved the idea of abiogenesis, or what's called spontaneous generation. He had refuted this. Francesco Redi had refuted it earlier than him, but this is one of these ideas that it's one of these. I think it's really a conception that the oligarchy has. One of these ideas that they really just want people to grasp onto in terms of enforcing overall reductionist thinking. So Oparin says in the introduction, he says, we need to come up with a better theory of abiogenesis, because I have to admit that what Redi did, what Pasteur did, they sort of did disprove this. And, for example, Redi's experiment was, people used to think that if you had a hunk of meat, it would start, maggots and things would start crawling on it. People would think that these things were just spontaneously, emerging from the meat. And he ended up showing, no, if you sterilize something, if you put the meat, if you put it in something, if you cover it, it won't grow maggots, because the maggots are actually, it's from light. It's flies are coming, they're laying their eggs. And that's where the living things are coming from. They're not spontaneously emerging from just a hunk of meat. So Oparin admits people did these experiments and they did sort of disprove this idea. So he says, I need to come up with a better theory. One sec. So here's what he does. This is the essence of his better theory. And I think it's very interesting, because what he does is, it's the most useful quote, because it comes across as also an attack on that in order to come up with a theory of abiogenesis, he finds the need to attack creativity or intention. So this is from Oparin's Origin of Life, which it is interesting. This was originally not a book. It was like a political pamphlet that was circulating on the streets of Moscow in 1923. It later became a book. Again, I mean, the guy was really he was a political tool. So this is what he says. So he admits, okay, Pasteur, Redi, these people, they disproved that, that life doesn't come from non-life, but I really still want to prove this. I really still believe in this. So this is what he says. He says, if the reader were asked to consider the probability that in the midst of inorganic matter, a large factory with smokestacks, pipes, boilers, machines, ventilators, etc., suddenly sprang into existence by some natural process, let us say a volcanic eruption, this would be taken at best for a silly joke. Yet even the simplest microorganism has a more complex structure than any factory, and therefore its fortuitous creation is very much less probable. All these difficulties, however, disappear if we take the standpoint that the simplest living organisms originated gradually by a long evolutionary process of organic substance, and that they represent merely definite mileposts along the general historic road of the evolution of matter. So in a sense, what Oparin is saying is the factor that was missing, the way that I can get around the experiments of Pasteur, Reddy, etc., people who refuted this, is really I'm going to cheat. I'm going to say given essentially an infinite amount of time, really, it's not that I can prove, but nobody could really disprove me if I were to say that given, you know, billions and billions of years, abiotic, non-living chemical building blocks could possibly interact in such a way that they could form a living organism. And he doesn't prove it, but when you argue in this way, of course, you're not actually proving something, you're saying, you know, why don't you disprove me? Now, if this is not totally clear to people, this is exactly analogous to something called the infinite monkey theorem, which states that a monkey hitting keys at random on a typewriter keyboard for an infinite amount of time will almost surely, not surely, almost surely type a given text, such as the complete works of William Shakespeare. So really, it is exactly the same. It's the exact same kind of argument. And the book is very, you know, it's very unconvincing in that way. You know, it's this very, very long book. He goes through sort of like the evolution of the solar system, hypotheses about what conditions and elements there would be in the primordial Earth, and it's all totally hypothetical, and ends the book and says, you know, can't you imagine that maybe, you know, after 150 pages, we almost surely could create, I think he ends with something like a pigment, right, which is, you know, just a certain compound with what he says are the living elements, or the non-living elements that form life: carbon, hydrogen, oxygen, nitrogen. And as Vernadsky will later point out, Vernadsky says this is, even making this kind of argument is a fallacy, because to explain the origin of life, you have to explain the origin of the entire biosphere. You can't try to explain how one organism came into existence, because we only know organisms existing in the context of a biosphere. But so this is his this is what he puts forward. Organisms are fundamentally abiotic. You can explain the origin of life through kinematics, basic laws of chemistry, throw in a little bit of lightning, maybe to catalyze the right kinds of chemical reactions, and basically just explains how you could create an organic compound, and says, you know, through the power of suggestion, okay, I can create that, possibly. Can't you imagine then how you could, you know, get all of life on Earth, which is pretty ridiculous, but it's actually really shocking, the extent to which people in the field of astrobiology, for example, we've encountered this at conferences, people really have grabbed on to this idea and accepted it as a way of thinking about life. And this is where Vernadsky, he really wages war against this. He wages war against this kind of reductionism coming from Oparin. And he, you know, one of the ways that I've thought about Vernadsky and also Lynn is, you know, Lynn did a very rigorous proof of how man and beast are totally fundamentally distinct. And what Vernadsky did, he really devoted much of his life's work with proving that same kind of fundamental distinction between living and non-living matter, between the lithosphere and the biosphere. And then, of course, towards the end of his life, although he surely didn't do it in such a rigorous way as Lynn did, he then, you know, took sort of that that experience and looked at human cognition and actually tried to see if he could make a similar similar argument, referring to the fact that there's also a fundamental distinction between simple living matter and cognition. So what I want to do, and this shouldn't actually take too long, is I want to show people. So this is sort of, the dregs. This is Oparin. This is how he thought. It's not rigorous. It's sort of like, you really feel like you're more like you're being bullied when you read his book, because, and it is this key in even this infinite monkey theorem. You're not actually asserting that, you're not rigorously asserting that something could happen. You're saying it almost surely could, given an infinite amount of time. I mean, it's really a very lazy reasoning. So what Vernadsky does, and Dennis referred to this paper, he, in 1938, writes a paper called Problems of Biogeochemistry 2. And Dennis actually read some quotes from this paper, where he has a whole paper, and then he has a table. And this is really and it's very funny, because Vernadsky and Oparin, although they did in a couple instances directly attack each other, Vernadsky is much more, he's a very sort of clever polemical guy. So his response to Oparin is essentially, he makes this huge table people have seen, where he has on the one side living natural bodies and inert natural bodies, and he goes one by one into different characteristics that he examines, showing why they are completely fundamentally distinct. So I just want to look at two of them to give people an idea of how he actually thought about this. So the first one, and I think people, again, I think some of these things, particularly this, people who've read Vernadsky have some sense of this. This is a discussion of chirality, or handedness, which he places a lot of importance of, and this gets directly at the importance that he places on the work of Louis Pasteur. So this is actually how he starts the table. He has something like, I forget, it's like 15 different characteristics that he looks at. So he starts with this. This is the first sentence of the table. And again, here you also see he is just slapping Oparin across the face. He says, the artificial synthesis of a living natural body has never been accomplished. This indicates that some fundamental condition required for such a synthesis is absent in the laboratory. L. Pasteur identifies dissymmetry, a special state of space, as the missing condition. A chemical distinction between right and left-handed forms of the same chemical compound characterizes the state of physical space occupied in the body of a living organism. Such states of space occupied by bodies of living matter are created in the biosphere only out of previously existing living natural bodies. They're generated by birth. Retty's principle. One can see here an expression of Curie's principle, and I'll get into that. But what Vernadsky ends up saying is, Retty says life comes from life. Curie's principle, and I will look at it a little bit, is dissymmetry comes from dissymmetry. So Vernadsky says these are, in a sense, saying the same thing. And it's why you don't have, you don't have abiogenesis. So contrary, on the side of inert natural bodies, totally distinct, he says right and left-handedness are geometrically and chemically identical in inert natural bodies. Both are always present in the same number and are chemically indistinguishable. It is a manifestation of the atomic construction on the one hand and of Euclidean geometry on the other. And this is the other point I want to look at a little bit, because also, Dennis provoked this in the webcast. He read some quotes from Vernadsky on this. So just to briefly give people an idea of this, what did Pasteur do? To sum it up quickly, Pasteur, here we have a picture of tartaric acid crystals, which come from wine. You can see they have they don't, they don't look like hands, but they have similar characteristic, or you would say a similar symmetry as your left and your right hand. You can sort of see that. So these were first actually isolated by Pasteur, these crystals. And the interesting thing about them is when you dissolve them, and this is using this apparatus called the polarimeter, which is, can't get into it all tonight, but so when you dissolve tartaric acid crystals, in a sense make a solution out of them, they still demonstrate a type of chirality or handedness. And the way that they do that is that if you have a polarimeter where you have a liquid, you have shining through that liquid plain polarized light that you polarize it by going through a certain kind of crystal. And after it passes through the solution, on the other side, the solution, if it's made from something like tartaric acid or something that comes from a living process, it will take that plane of polarized light and rotate it to the left or the right, depending on what it's made of, depending on how many of these left or right-handed crystals were composing it. Now, interestingly, this is not true for other handed crystals which don't come from life. For example, on the bottom here, you see two other crystals that have this similar appearance. They sort of look like left and right hands. These are quartz crystals. They're handed. In a sense, they look similar to the tartaric acid crystals, but when you dissolve them in a solution, in a polarimeter, they lose any sign of chirality. They won't rotate polarized light. So this was, summing up very quickly, the essence of Pasteur's discovery and some of the experiments that he did. And this is really all that he asserted. He asserted this very interesting difference. This is a little bit backwards. So above, this is what people then did with Pasteur's discovery. Although I think he's very interesting. He did this experimental work. I think similarly to Vernadsky. He said he wants to, he did experiments. He made empirical generalizations. He really didn't want to propose a model for what he thought was actually happening. He simply said it's very interesting that even when you dissolve the tartaric acid crystals, there's a handedness there that exists on a more fundamental level. He didn't say what it looked like. Today, the way this is discussed today, because what Pasteur did was revolutionary and impacts modern science to this day, people have devised a model of handed molecules, which come from these asymmetric carbon tetrahedra. And so what we now know today is all compounds in the human body, all proteins essentially, are left-handed. Sugars are right-handed. There's very little variation from that. If you had a left-handed sugar or a right-handed protein, they would behave totally differently. If you this affects medicines, the left or right-handed form of a compound in a medicine can, treat totally different symptoms. Like the left-handed form will treat a cough, the right-handed form will, treat morning sickness or something like that. Completely different. And this is totally unique to life. In the domain of simple non-living chemistry, this distinction between left and right does not matter. So moving on here. So just to give people a sense of, so there's the work of Pasteur, and Vernadsky was further convinced, you could say, of its importance because of the work of someone named Pierre Curie, which people also might be familiar with from reading Vernadsky's work. He's also the husband of Marie Curie, who made important discoveries in the domain of radioactivity. So again, I'm just putting these things out there because I also think people have probably seen some of these things in Vernadsky's papers and maybe never, never then. It's good to get things straight from the horse's mouth. So this is what Pierre Curie says about symmetry, dissymmetry, and this is why Vernadsky thought that the discoveries of Pasteur meant something really significant. It meant that life and non-life were completely, fundamentally different. So what Curie says in one of his papers, he says, when certain causes produce certain effects, the elements of symmetry of causes have to be found in the effects produced. When certain effects reveal a certain dissymmetry, this dissymmetry should be found in the causes which gave birth to it. Now that is, so people can look at that. I'm going to read from what Marie Curie says and about this, which I think makes it a little bit more clear. And unfortunately, Pierre Curie, he died very young. He actually died while he was working on this. What we do know is that Vernadsky met Marie Curie, and what I'm going to read from is a book that we know Vernadsky read. Marie Curie wrote a biography of Pierre Curie, and Vernadsky read this. So this certainly is what informed some of his thoughts, as well as whatever else he read and whatever discussions that he had with her, which maybe are things that we'll never know exactly what those were. So she said it was the study of optics which first showed that the propagation of light in a crystal is dependent upon the elements of symmetry in that crystal. The same thing is true for the conduction of heat or electricity, for magnetization, for polarization, etc. It was in reflecting upon the relations between cause and effect that govern these phenomena that Pierre Curie was led to complete and extend the idea of symmetry by considering it as a condition of space characteristic of the medium in which a given phenomenon occurs. So again, he's saying symmetry is reflective, and different symmetries are reflective of what he calls a different state of space. And he applied this to his work. He discovered piezoelectricity, where he was directly relating the symmetries of given crystals that piezoelectric crystals, which are crystals where when you compress them, they generate an electric current. And he related that effect with symmetry of crystal. He said he forecast that certain crystals, based on their structure, would be able to do that because of this idea he had of certain dissymmetrical effects that would have their source in a dissymmetrical cause. So yeah, I think what she says is clear. Pierre Curie was led to complete and extend the idea of symmetry by considering it as a condition of space, characteristic of the medium in which a given phenomenon occurs. So here we see, so then, so Vernadsky, he's looking at Pasteur, he's looking at Curie, he's looking at more experiments that people did since Pasteur, and he said, hey, this left-right distinction, this indicates that living matter is a different state of space. And also just getting back to the idea of how this relates to the second triad, Vernadsky is using this language and also uses it explicitly, and I can't remember if Dennis had a quote reflecting this. He's using this language, state of space, in the context of Einstein's work on physical space-times, different types of space-times. So he's discussing it as a possible extension of Einstein's work. Einstein, he's looking at gravitation and curved space-times, and Vernadsky says, hey, it looks to me like living matter itself is a unique state of space. And Vernadsky, and we don't have time to go into it tonight, but he also takes into account that for Einstein, with Einstein's discovery, space and time were not separate. So for Vernadsky, if you observe this kind of unique handedness and dissymmetry of living matter in its space, you should also, if that's fundamentally distinct from non-living matter, then its time also should be. And he discusses this in this paper. He says, uniquely, the biosphere creates free energy, irreversible progress. He discusses this as a characteristic of time. He has these categories. He talks about geological time, biological time, historical time. looking at these as really, you know, different ways to measure the transformation of the biosphere in historical time. Changes, you know, with man, of course, you get a much more rapid transformation of the biosphere. So these are things that he discusses, but you know, they're in this context. He's saying life exhibits a unique state of space. It also has unique temporal characteristics. Now just one more thing on this, just to give people an idea, you know, because Dennis did put this forward in the webcast, and it's very provocative. And I read this quote from Vernadsky where he says that this is in defiance of Euclidean space. Now, I don't know the full answer to that. I think it's provocative. Vernadsky wrote to different mathematicians and asked them to try to figure this out. One thing that I can give people, which I think is it gives people a certain sense of how to think about it, is something from Immanuel Kant. He wrote about this, I think in German it's called das Rechts-Links-Problem. It's this problem of left and right. For him as a philosopher, how do you actually describe, how do you actually demonstrate that they are different? And he brings this up as a geometrical problem, that in the domain of geometry, left and right are essentially the same. This is what he says. This is from his 1770 inaugural. He says, there being imperfectly similar and equal, but incongruous solids, such as the right and left hand, conceived of solely as to extent, or spherical triangles in opposite hemispheres, a difference rendering impossible the coincidence of their limits of extension. Although for all that can be stated in marks intelligible to the mind by speech, they are interchangeable. It is patent that only by pure intuition can the difference, namely incongruity, be noticed. So just to restate that briefly, he's essentially saying, you know, if you think of your two hands, he says spherical triangles are your two hands. If you think of them as just geometrical shapes, volumes, and if you're going to describe them, you come up with an identical description. If you were to you know, try to trace them out for somebody, if you were to measure them as volumes, assuming they were exactly the same size, you can't actually come up with any way outside of arbitrarily naming them, saying, well, this is my left hand and this one is just not my left hand. So I'll say not my left hand is my right hand. He says there's no absolute difference. They're totally the same. This is the only way yeah, there's no absolute difference between them. And you know how Kant is. He sort of says this is just left and right. This is just an a priori idea. You know, it's just you're hardwired for it, and you know, he's perplexed by this. Left and right, they're different, but I can't actually describe how they're different with geometry. Now, you know, a maybe too simplistic way of looking at this is, you know, looking at your hands as volumes, where you know, come up with an identical description for either of them, and unless you're perfectly ambidextrous, you know, your hands as part of a living organism, they're functionally totally different, right? That in terms of their function, you know, your right hand can do things that your left hand can't. It's one manifestation of this difference of left and right in living matter or in the human body. So simple geometry can't distinguish left and right, but life does. That's just one thought for people about that. Now, given the time, I'm actually just going to end here pretty soon. So anyhow, this is what Vernadsky puts forward. I would like to, maybe we could do this another time, go through another thing that he brings up is this distinction between how life treats isotopes versus inert matter, but I'm not actually going to get into it. And I guess that actually makes it easier to just discount with, sort of dismiss Oparin, because Oparin's actual response to this, his only lame response to this, for example, coming from Vernadsky, is there's in the 1950s a symposium called the Symposium on the Origin of Life on Earth. And this is where Vernadsky Oparin most directly attacks Vernadsky. And all he says about this is, well, Vernadsky made a big deal about the left-right distinction in living matter, but you know, I found this one paper that he just wrote, and he doesn't even bring it up. So I guess he must have realized that it wasn't that important. And he literally just dismisses with it like that. Then what he actually gets into, which we should just save it for another time, he was actually much more disturbed in terms of his own theory, disturbed by the differences in how life deals with isotopes as opposed to non-life. But I don't think I'm going to get into that. So I'm just going to end with a quote from Vernadsky, looking at. So ultimately, all of this work informs how he thinks about the noosphere and how he thinks about the even higher power, or you could say, in Curie's language, which I don't expect people to, you know, have a total handle on. Curie would say a higher dissymmetrical cause of the human mind. So this is from a translation that I recently did. We put this on the website on the in March on the as we closed out the 150th birthday anniversary year of Vernadsky. And this is one of the most provocative things in there. So this, it's called On the Conditions of the Appearance of Life on Earth. I couldn't, you know, maybe at some point we should just have something on that. But what Vernadsky does in there, that is the most direct thing I've seen where he really just goes after this theory that life came from non-life on Earth, and is really defending the idea of life as a distinct principle. But what he gets to is very interesting. So I want to read this and then end, and we can take some questions. Unfortunately, we started, you know, like 25 minutes late. So what he says in there, he says, man can create in laboratories environments of enantiomorphic structure possessing some properties of dissymmetric enantiomorphic structure characteristic of life. Enantiomorphic means handed, you know, this left-right thing. However, man has not succeeded up until now in creating a dissymmetrical environment analogous to that which we find in the interior of organisms. The study of the action upon living phenomena by environments formed by left or right-handed circularly polarized light opens a field of great interest, but it is not a dissymmetrical environment similar to that of living organisms. It is necessary still, always, to have in view, according to the principle of Curie, that the activity of man would be itself a dissymmetrical cause, and the creation by him of a dissymmetrical environment responding to life would be a normal event from the point of view of dissymmetry. I forgot to show people that quote. So just to say something about it, it's quite shocking. In a sense, Vernadsky's, this entire thing, he's saying a living organism cannot be synthesized from the bottom up. That it, you know, life has a higher power, and he has all these, you know, ways that he looks at demonstrating that. You can't get the synthesis of a living organism a la Oparin from non-living chemical building blocks up to life. You're not going to get that. That's not how things work. There's a top-down organization, you know, where life is a superior principle to non-life. But so he says, well, you can't go from the bottom up. You could go from the top down. That if mankind understood actually understood, and he's saying mankind doesn't yet, if mankind actually understood the principle of life, from the standpoint of Pasteur, Curie, if mankind actually understood this unique state of space that is life, if were mankind to understand that, he could maybe synthesize a living organism from the top down in that sense. That you can't get a bottom-up synthesis of life, as Oparin said, but Vernadsky said you could get it from the top down, from the noosphere, because human creativity is more powerful. Anyhow, my mind was really blown when I read that. Anyhow, so I'm just going to end there. So it's something, as I said, something more that's really more things which I think come up a lot in many of Vernadsky's writings, which I wanted to lay out for people. But so I can take questions now on any of that, or just anything people have been thinking about Vernadsky, the noosphere, or any of this. So anyhow, I'll open it up to you guys. Or anybody here in the audience? That was a lot. But
I have a question.
mm-hmm.
Was there any, or what do you know about the interaction or scientific dialogue between Vernadsky's circles and Einstein and Planck?
Meghan asked if we knew anything about the actual interaction between some of Vernadsky's scientific circles and those of Einstein or Planck.
Even if it's just like when they're, writing ideas.
Yeah, I mean, I think, and now that I'm thinking about it, I can't actually think of anything really, really direct that I know of in terms of that discussion. I think what is most clear is Vernadsky is, especially in this paper, this Problems of Biogeochemistry 2, and we can probably put the link in people can find it, but make that available. He's very explicit that he's situating what he's doing in the context of this revolution that he refers a lot to Einstein. I haven't seen him refer to Planck, but he's situating his work very explicitly in the scientific revolution that Einstein made, and I think so that much is very clear. But I think I remember at one point reading through these Einstein anthologies and trying to find, did these guys, Vernadsky talked about them, did they talk about him in the sense, did they write about life in this way? But I think I didn't really come upon anything specific in that respect, but it doesn't really matter, because what they all do is they all jump to the human mind. Einstein, Planck, and Vernadsky. So, I mean, it would be good to get a better sense of this. I mean, we do know Vernadsky was very aware of Einstein, the other way, in terms of Einstein and Planck being aware of him. Maybe not so much specifically, but I think there's a reason why they all existing in this 20th century scientific dark age naturally all came to this emphasis on the powers of the human mind as subsuming really any other domain of science. So, but yeah, it would be good to actually get a better sense of that.
question for the Overton.
Okay. Ian says, what you just read makes it seem impossible for life to have formed on Earth by any other means than interstellar colonization. Does Vernadsky comment about that? Well, I really, this interstellar colonization, he does bring up, I guess one way I've heard that is he brings up the possibility of panspermia, which is life actually being transported to Earth from somewhere else in the cosmos. And I'm really torn about spoiling the conclusion in this translation. He says something, I'm not sure whether to spoil it for people. What he ends up saying is that it has to do with what he does. He does something very interesting. He gives people a lot of some of what I went through, Pasteur's work, Curie, and you're sort of saying, you know, given these conditions, how on earth would life have been created? That there would have had to be some kind of what is the dissymmetrical cause that would allow for the appearance of life on Earth. And what he comes to is actually he traces the moment of the appearance of life on Earth to the separation of the moon from the Earth. And this is a theory. This is one of the it's very interesting that the formation of the moon is not settled. One of the theories is that it actually came from the material of the Earth. And he describes an event that is, it's not clear. He basically describes a cosmic, let's just say a cosmic event which disrupts, is very, the Earth, it's very disruptive in a sense to the Earth, and the material of the moon gets flung off. He actually goes through how the magnitude of size of the moon is similar to the magnitude of the size of the Pacific Ocean basin. And he says that this kind of event, and this is where it'd be good to read more about it, it's some kind of, I don't know, like cosmic earthquake. It's a little bit vague what he describes. But something that really shakes the Earth up. It almost sounds like he's talking about, of course, at that time there wasn't the moon. He actually talks about the Earth itself being subject to some kinds of tidal forces. I don't know whether they came from the sun or what. Anyhow, some earth-shaking event causes the moon to separate from the Earth, and he says imparts, with that event, with the formation of the moon in that way, imparts a dissymmetry to the otherwise spherical Earth, which created the conditions for life to be created. So that is a really wild hypothesis, but I think what you'll find, in a sense, if that happened, that would be amazing. And he actually goes through how scientists could study this. He said you should study these rocks and figure out, before and after the time when the moon would have separated, are there traces of life? Are there not traces of life before? Traces of life after? It'd be good to actually follow this up. But in a sense, it's almost like whether or not that's true. His reasoning is very rigorous. His reasoning is from this standpoint that in a sense it would have to be some kind of, it would have to be this particular kind of event because of what he had set up about how life, these sort of impossible or these very specific conditions that would allow for the creation of life, which have to do with its symmetry, etc. So anyhow, in terms of, yeah, that's what he says about it, and I was quite shocked. Anyhow, people can check it out in the translation. Okay. Bill Roberts says, to say that what is missing in the laboratory, which accounts for why life cannot be generated from non-life, is a special state of space. Isn't that like saying that what's missing is not constituent parts, but what is missing is that specific quality and organization of action, which we recognize as being specific to living things, since space is not... Anyhow, I understand what you're saying, and I think that's very much the point. He's saying, he's not just saying that, because of course he's talking about man. He's not just talking about that any man could do this. Of course, you know, could Oparin do it? And there's a whole interesting thing which I actually go through in this article as to the various failures of people trying to replicate Oparin's experiments. And it's very funny because, for example, they'll create amino acids. I mean, one is it's ridiculous to say that that you create an amino acid and that means you could get a living organism. I mean, nobody ever said you could get a living organism from a pile of amino acids. But interesting things came up in the failures of these experiments where they would create amino acids, but they were of the wrong handedness, things actually relating to this per se. So I think Vernadsky is saying, he's saying that man could do this, but man would have to have an understanding of, you're right, not the constituent parts of life, but what is it, this somewhat vague but yet very precise idea of what makes living matter unique, that it has all of these very different spatial and temporal characteristics than anything else. So I think you're right. It's that he's saying that's the condition that man could, that it would be, we could envision that man could synthesize, if we have this ordering of the phase spaces, that you could get a top-down synthesis of life, but it would have to be, it can only be done by man who actually understood the principles of organization of life. And yeah, this is where the approach today is completely wrong. And we had a lot of fun a couple years ago at the, we got invited. I actually proposed a poster to a NASA astrobiology conference on this, on Oparin versus Vernadsky, and it was selections from this table. And it was very shocking to be there. Everybody knows who Oparin is. I met one guy, this professor from New York, who he came up to the poster, he saw Vernadsky, and he said, "Ah, Vernadsky, that towering figure of science." Everybody else just knew Oparin, and as I said, Oparin made a trip to NASA Ames in 1969, and what you get today in astrobiology, it's just this. The study of astrobiology has basically been reduced to this Oparin view that if we're looking for life, we're looking for carbon, hydrogen, oxygen, nitrogen, compounds of those, conditions that would allow for certain types of compounds of those elements to form. So that's very much the approach today, and it's not like astrobiology. Certainly, there's interesting work being done, but have they made a breakthrough? Really, in a sense, what we tried to get people to think about there. I mean, would these people, if they ran into life or fossils of life, would they even recognize it? They've got such a narrow view that is so centered on life as its constituents. And one of the things from this paper that sort of freaked people out at that conference was I took this sentence from it where he said, "There are no living elements," because that is their view, that they're carbon, hydrogen, oxygen, nitrogen, those are the living elements. And he says there are no living elements. So yeah, I think you're totally right. I think that's really the point. Yeah, he says in the quote, he says, Yeah, he talks about what man would create would be a dissymmetrical environment responding to life. That would be possible. So yeah, and yeah, it's hard to wrap your mind around exactly how that would work, but I think he gives us the right questions, and the point is also there's specific applications, but that I think the beauty of what Vernadsky does with this is it's very much central to it is the idea of there being these phase spaces that Lynn talks about, and that's, I think, a lot of Lynn's focus on Vernadsky, that there are these three phase spaces, and they have a top-down ordering, and Vernadsky has his own way of getting at that, and Lynn gets, and Vernadsky does it more with life and non-life, Lynn with human creativity in life, but yeah, that's what he gets you to think about with this.
Megan, you can hear me? Oh, okay. What you're saying reminds me of what Darwin had to say about the appearance of human consciousness, right? Which is that he has this whole theory that he lays out how the proto-man, the ape proto-man, gradually over millennia learns to do things that require more and more of some kind of, conscious ability to deal with his environment, and that it's the slow buildup over time that creates a human mind from the ape, rather than the top-down kind of appearance of it. But of course, that begs more of a religious kind of concept than even just where does life appear, right? Because, of course, the appearance of human consciousness has got to be top down. It's not going to be the slow buildup from, some animal that over millennia slowly becomes more human. So, yeah. So anyway, Darwin and the Oparin creeps, they got the same conception.
Yeah, and as I mentioned, it was very interesting for me to find people said, well, Oparin didn't, he had theories about evolution, but he didn't really write any, he didn't have theories about the living organism per se. So it was very interesting that he put forward a very, really exactly Oparin's argument. But I mean, one thing I noticed from looking at, it's really, these guys imposed reductionism on two levels. On the one hand, it was more explicitly with Darwin and this Huxley-Wells book, and also a later book, a really evil book by Julian Huxley. He wrote a later book called, it's on evolution. He wrote this book in the 50s, his own book. And what all these guys attack, so on the one end you have Oparin, you have reductionism, in terms of looking at the living organism per se, but then, they also, and they're very much related, what Darwin did and what these guys wrote about is wanting to impose reductionism on, evolution as a whole. And what they always attack, they always use this word, they attack the idea of purpose in evolution. And I know people who like, they like Vernadsky's stuff, but when he talks about purpose and evolution, they freak out. And they, in terms of what you're saying, they freak out about the idea that, that there was an intention, in evolution to produce man, that was sort of the seed, that intention was there from the beginning, rather than saying, okay, there were some random interactions and, chaos, etc., and we somewhat by chance got man. A lot of these people, Stephen Gould, a lot of these people who write about biology, evolution, they really react on that specific point. And they say, for this reason, Bertrand Russell says this, they say for this reason it's false for man to you know, have such a self-important view of himself, to think that things evolved with the intention of producing him. No, he just randomly, you know, he's lucky he was lucky he was produced, you know, but it had nothing to do with him per se. You certainly couldn't say that things were tending towards the production of man, because there was that kind of intention from the beginning. So I think you're really right, and this is what you find much later than Darwin, even in most people's writings on evolution. Yeah, Stephen Gould comes to mind, but this is what's in the this Wells-Huxley-Wells book, and Bertrand Russell wrote explicitly on this, the idea of you know, man's false sense of self-importance, as though evolution was tending towards his own creation. And he gives a lot of terrible examples of where, you know, we have this false sense of self-importance. Look at all these creatures in the, I mean, he's quite an ugly guy, of course, but he says, look at all these things in the biosphere. They're so much more beautiful than we are. Lions and tigers, and they're so nice to look at. And, you know, why do we think we're so important? Yeah, anyhow, that's a good point. Natalie, were you? Did someone have a question? Okay. Dash asks, does the radiation exception have anything to do with spin? That only life creates free energy, with the exception being radiation. Does the spin of radiation particles, waves get discussed anywhere? I don't really know. Did I actually even mention that? I thought I forgot that. Oh yeah, I didn't say it, but it was on the slide, so I should bring it up. Vernadsky says, interestingly, what he's talking about the different temporal characteristics of life. He says, here. He says, I guess I didn't need to go on it. But he says, yeah, the biosphere is unique in that it creates free energy. It has irreversible progress. Non-living chemical processes, they're reversible. And he interestingly says the exception in the domain of inert natural bodies, the exception to this creation of free energy is radioactivity. And that's a lot of how this table, he's also looking at that there are things that are not usually the case. There are exceptions in inert natural bodies, but they're always characteristic of life. For example, you know, the biosphere, it always creates free energy, has this tendency towards irreversible progress. Not so much in inert natural bodies. It's mostly chemical reactions which could be reversible, but there's an exception when you get radioactivity. You have the creation of free energy, etc. So I don't actually think I said that point, just to say it. In terms of your question, yeah, whether this has to, yeah, I don't quite know how to respond to your question. I'll just say there's a very interesting footnote in the biosphere about spin and whether this also plays a role in the unique symmetry of living organisms. And yeah, that's about what I can say on that. That was something I actually wrote to Mark McMenamine and asked him about that, and I didn't really get much of it. I didn't really get a satisfactory answer. But yes, that's how I'll respond to your question. I don't quite know the answer. It is interesting to think about spin in the context of this discussion of symmetry in general, because it's sort of that kind of has that kind of quality. That's what I'll say.
I can say something on that question
Yeah,
of spin, which is early on in quantum physics when they were looking at you know, these short-lived particles that were the result of the bombardment, you know, of protons at each other. They were coming up with an asymmetry in the spin of the product particles that was resulting from this this bombardment. And so what they did was they came up with this whole CPT theory, the charge and polarization and time, where maybe you'd get an asymmetry of spin in your product particles, but it would be balanced out because your charge would be changed. You know, you'd go from having a minus charge to a positive charge. In other words, you'd end up with the production of antimatter particles. And so, you know, they came up with this whole theory about how to balance this out. But there was a very interesting anomaly that showed up. I think it was in experiments in 1964. And these two fellows, Val Fitch and the other guy, I can't remember his first name, his last name was Cronin. The two of them got a Nobel Prize in 1980 for finding an asymmetry in these products that meant that there were actually more antimatter particles being produced than matter particles. There were more positrons being produced than electrons in this process. And Val Fitch, when he gave his Nobel Prize acceptance speech, said, well, maybe this anti-symmetry that we're looking at here can, when it occurs through the bombardment of Earth's atmosphere by cosmic radiation, maybe this is actually encouraging the production of an asymmetry that has to do with the universe at large being able to produce asymmetric phenomenon. And it was a very interesting kind of question that he was posing here that was very unlike any of these other quantum mechanist characters that are working in this field. And he was trying to pose something on a cosmic scale that was in defiance of the second law of thermodynamics, the idea that everything is running down to, you know, a soup kind of thing. And anyway, I thought that was interesting. But this question of asymmetric spin in these reactant products may be what was prompting Vernadsky to pose questions about particle spin. That's it.
Just to clarify, I haven't seen him actually pose anything about that.
Oh, I thought you said there was a footnote where he said something about spin.
Yeah, it was a footnote by
a commentator.
Yeah, it was a footnote, and I tried to actually follow something up about it, but that was actually more people wondering if ultimately the symmetry of living organisms, would it also relate to that or come from that, and how does that function inside of a living organism, which I think is pretty interesting. I wasn't able to come up with anything fruitful, and maybe it is related in a certain way to why it is an exception, but I think we also know something about nuclear power and how it creates free energy. So yeah, it certainly is a unique, although Vernadsky is saying uncharacteristic phenomenon in inert natural bodies in the lithosphere. And he was actually also pretty interested in radioactivity and, you know, what kinds of radioactive processes do you have going on inside of a living organism. He did work, there was a whole, he talks about this a lot in the Problems of Biogeochemistry 1 paper. He talks about actually trying to work on this and look at this in the laboratory. Life's incorporation of radioactive material. And, yeah, it's another angle on it.
Megan?
Yes?
This is Renee. Just
Hi.
quickly, Gauss actually wrote an attack on Kant's discussion of chirality, which we published.
Yeah.
And it's interesting. It was in his typical Gauss, restrained manner.
Yeah.
But it is interesting, and it really, and Kant really was a bulwark of attacks on Kepler.
Mm-hmm.
It's easy to document that. It's useful to do that, and of course Leibniz. But I think you get these two branches, very clearly then, which are radiating through Germany and through Russia, which is the fight against this. And in terms of at least the aspect of chirality, people, the obvious point should be underlined that all of these people that were interested in this were musicians, and of course. The phenomenon of inversion in music is a beautiful, enhancement of implications of this. That it's not a mirror image. That there's actually distant symmetrical processes going on when it's left versus right. Music is a beautiful example of that. So it already bespeaks the question of the human mind when you're fascinated with this.
Yeah, thanks. That's a good point. And I'm remembering now, I was actually trying to remember today, why did I come across this Kant paper? And I think it was coming across something from Gauss, but that was so, I felt like I needed to actually find the Kant paper because Gauss was being, a little bit too subtle. But yeah, thanks for bringing that up. Anybody else? Going once? Going twice? I think that was a very good, I'm happy with that discussion there. And really, I mean, Vernadsky is he's so amazing, and I mean, there's so much to much to say about him because similar to Lynn, he was not, and he actually writes in his it's in the Bales biography that he struggled at one point with the idea of being a specialist and just actually trying to master everything, and I think that's definitely what he strove for, and for that reason he just has there's just such a wealth of material and ideas there, which then are given a whole new context by Lynn's work. And I think, had Vernadsky lived past World War II, when we know his later writings, he was then sort of taking this model of this rigorous argument he made, looking at the difference between life and non-life, and actually looking at the distinction, the tremendous power of the noosphere compared to the biosphere. I think if he had lived much longer, I think that he probably would have actually tried to work on this. I don't know that he would have came to the same kinds of conclusions as Lynn, but I'm sure that this was actually a direction that he would have gone with this, is the distinction between man and beast. So anyhow, I think we can wrap up there. Really happy that, I'm sorry that there were 25 minutes of technical difficulties, but yeah, but I think it turned out pretty well, and happy that people got on and had some really good questions. So, and as I said, we'll send out an invitation. People can look forward to just continuing this discussion about Vernadsky next week with Bill Jones, which I'm certainly looking forward to. So, okay, talk to you guys later. Bye-bye. Bye. Thanks. Bye. I can do this.